In today's class, we will start about classification of materials. So what are the different classification of materials? Mainly the materials are classified depends upon the energy gap. So the materials are classified into conductors, semiconductors and insulators. So the classification of materials, these materials are classified depends upon energy gap. So what is mean by energy gap? The difference between the top of the valence band and bottom of the conduction band is called as energy gap, where the top of the valence band is having energy gap as E suffix C, and the bottom of the conduction band is E suffix phi. So Eg is equal to Ec minus Ev. So this is called as energy gap. So what is mean by valence band? So valence band is nothing but the energy levels which are associated with valence electrons is called as valence band. Similarly, what is mean by conduction band? The energy levels which are associated with conduction electrons or free electrons is called as conduction band. So the valence band means the energy levels which are associated with valence electrons, and what is mean by conduction band? The energy levels which are associated with conduction electrons or free electrons. So what is mean by conduction electrons or free electrons? So the current will occurs due to mainly these conduction electrons or free electrons. But as valence electrons, these valence electrons will present in the outermost orbit of a particular atom. So if we are going to take silicon, silicon is having 14 atomic number. It is having 4 valence electrons in its outermost orbit. 4 valence electrons. So how we can tell that it is having 4 valence electrons? If I am going to take its structure, silicon first orbit, second orbit and third orbit. So each orbit is having the number of electrons is specified by 2n square. That means the first orbit is having 2 into 1 square, that is 2 electrons. Similarly, the second orbit is having 2 into 2 square, that is 8 electrons. So 2 square 4 into 2 8 electrons. So the first orbit is having 2 valence electrons. First orbit is having 2 electrons. The second orbit is having 8 electrons. And similarly the third orbit. So third orbit actually it has to occupy 18 electrons. But as its atomic number is 14, only 2 plus 8 plus 4. That means only 4 electrons is occupied in the third orbit for the silicon. So whatever or how many number of electrons present in the outermost orbit of a particular element is called as valence electrons. So these valence electrons will be occupied at the outermost orbit of a particular element. But these valence electrons cannot able to conduct until it will become as free electrons. So what we have to do is we have to apply sufficient energy to these valence electrons to become as free electrons. So that is nothing but energy gap. So the energy gap is nothing but it is the difference between conduction band and valence band. So how many number of valence electrons present in it, and what is the energy associated with it? It is present in valence band. So these valence band electrons has to become as free electrons. So for that purpose we require to give sufficient energy to become as free electrons. Whenever these valence electrons will become free, so if we are going to apply sufficient energy, these free electrons will start to move from one place to another place. Then only the charge is going to be accumulated and the current is going to start. If the free electrons also present, and if it is not in movement position, the current is not going to be formed. So we come to know about what is mean by valence band and conduction band. Now we will compare the differences in conductors, semiconductors and insulators. So mainly we have seen that the classification of materials has done depends upon energy gap into three types, that is conductors, semiconductors and insulators. So again the semiconductors are classified into two types, that is direct band gap and indirect band gap. So what is mean by direct band gap semiconductors and indirect band gap semiconductors? So if we see the top of the valence band and bottom of the conduction band, if both are having, if both top of the valence band and the conduction band is having same momentum like this, that means how much amount of momentum is there present present at the top of the valence band, the same moment will be present in the bottom of the conduction band, then we will call it as a direct band gap semiconductors. And in indirect band gap semiconductors the moment is going to be different, that is if the momentum of the valence band is going to be like this,